In 1998, two independent teams of astronomers were looking at distant exploding stars to measure how the universe was slowing down. Instead, they found it was speeding up. The result was so wrong, so backwards, so completely opposed to what every model predicted, that both teams spent months trying to find the error. There was no error. The universe was accelerating, pulled apart by something invisible that filled empty space itself. Physicists gave it a name. They called it dark energy, and when they finally calculated how much of it there should be, based on the most successful theory in the history of science, the number they got was wrong by a factor of 10, followed by 120 zeros. Not 10 times wrong. Not 1,000,000 times wrong. A 1 with 120 zeros after it. This is the worst prediction in the history of physics, and it has not been fixed. It has not been explained. It sits at the center of modern cosmology like a hole in the floor of a house everyone agrees is still standing. What you are about to hear is not a failure of measurement. It is a failure of reality to behave the way it should. And the explanations physicists are now forced to consider, the ones that actually survive scrutiny, do not just rewrite a textbook. They rewrite what it means to exist at all. We will get to those explanations. But first you have to understand what kind of mistake we are actually staring at, and why every honest physicist who looks at it long enough eventually goes quiet. Because the universe should not be here. Not like this. Not tuned this way. Imagine you are at a mixing board with around 30 dials. Each dial controls a different fundamental property of reality. One dial sets the strength of gravity. Another sets how strongly atoms hold together. Another sets the mass of the electron. Another sets how much dark energy fills empty space. You don't know what the dials do until you turn them. You just know that somewhere on each dial there is a setting that produces a universe with stars, with chemistry, with planets, with the possibility of something looking back at the universe and asking why it exists. Every other setting produces nothing. A dead universe. A universe that collapses in a microsecond. A universe of pure radiation with no atoms. A universe where gravity is so strong, stars burn out in a year. A universe where gravity is so weak, nothing ever clumps together. You walk up to the mixing board and you find every single dial sitting on the exact narrow setting that allows the cosmos to produce you. That is the situation. That is what the data says. And the science behind that statement is not speculative. It is the work of decades of independent measurements by different teams, using different instruments, on different continents, all converging on the same uncomfortable conclusion. Take the cosmological constant again, the amount of dark energy in empty space. Quantum field theory, the framework that gives us the most precise predictions in the history of science, predicts that empty space should be seething with energy. When you do the calculation, the value you get for the energy density of the vacuum is enormous. If that value were correct, the universe would have ripped itself apart in the first fraction of a second after the Big Bang. Galaxies could not have formed, atoms could not have formed. The expansion would have been so violent that nothing could have clumped into anything. But when astronomers actually measure the cosmological constant, by watching how distant supernovae move, they find a value that is not 0, but is so small that it is 1 part in 10 to the power of 120 smaller than the theoretical prediction. Steven Weinberg, who won a Nobel Prize for unifying two of the 4 fundamental forces, called it the worst failure of an order of magnitude estimate in the history of theoretical physics. He spent the last decades of his life trying to understand why the value is what it is. He did not solve it. Nobody has. And dark energy is only one dial. In 1999, the British cosmologist Martin Rees published a small book called Just 6 Numbers. In it, he laid out 6 dimensionless ratios that between them determine almost everything about the structure of the cosmos. The strength of gravity compared to electromagnetism, the efficiency with which hydrogen fuses into helium, the amount of matter in the universe, the strength of dark energy, the seed of cosmic structure, the tiny ripples in the early universe that grew into galaxies, and the number of large spatial dimensions, which happens to be 3. 6 numbers, that's it. Change any one of them by a small amount, and you get a universe that cannot host you. The strength of gravity relative to electromagnetism is around 10 to the power of negative 36. That is the ratio you live inside. Make gravity slightly stronger, and stars burn out in millions of years instead of billions. There is no time for evolution, no time for chemistry to build the long molecules life needs. Make gravity slightly weaker, and stars cannot form at all. The universe stays a thin gas forever. The efficiency with which hydrogen fuses into helium inside stars is about 0.007. 0.7% of the mass of 4 hydrogen nuclei is converted to energy when they fuse into helium. If that number was 0.006, the strong nuclear force would be too weak to hold a deuterium nucleus together, and the chain reaction that builds every heavier element would never start. There would be no carbon, no oxygen, no iron. The universe would be a fog of hydrogen forever. If the number was 0.008, hydrogen would fuse so eagerly that all of it would have burned in the first few minutes after the Big Bang, leaving no fuel for stars and no water for anything to live in. 0.7%. That is the difference between a universe with you in it and a universe without. It gets sharper. The strong nuclear force, which holds atomic nuclei together, is also tuned on a knife's edge. The physicist Fred Hoyle worked this out in the 1950s when he was trying to understand how carbon, the element your body is built from, could exist at all. The path inside a star that produces carbon goes through a fragile quantum resonance. Hoyle predicted, before anyone had measured it, that this resonance had to exist at a specific energy, otherwise no carbon could form anywhere in the universe. He was right. The resonance is there. And later analyses have shown that if the strong nuclear force were about 2% stronger, 2 protons could bind directly to each other, and almost all the hydrogen in the early universe would have fused into helium-2, leaving no hydrogen behind for water or for stars that burn slowly enough to allow planets to develop. If the strong force were about 2% weaker, the deuterium needed as a stepping stone to all heavier elements would not be stable, and stars would not ignite at all. 2% in either direction, and the universe has no chemistry, no biology, no minds. Now widen the lens. Because Reese's 6 numbers are only the beginning. Dial down the mass of the electron, and atoms get bigger and softer until chemistry stops working. Dial up the mass of the neutron by about 1%, and free protons would decay, leaving a universe with no hydrogen at all. The ratio of matter to antimatter in the early universe is around 1 part in a billion, just enough surplus matter to leave behind the galaxies and gas you see, and not so much that everything would have collapsed into black holes. Even the dimensionality of space matters. In a universe with 2 large spatial dimensions, the equations that describe nerve impulses and signal propagation simply do not allow complex circuitry. In a universe with 4 large spatial dimensions, planetary orbits are unstable. Push a planet slightly off course and it spirals into the star or out into the dark. 3 is the only stable choice. You live in 3. You start to feel what physicists feel when they sit with this for too long. It is not one number that is suspicious, it is not 2, it is the entire panel. And every time someone tries to find an underlying law that forces the dials to take these values, they fail. There is no equation, in any version of physics anyone has constructed, that predicts the cosmological constant must be small. There is no theorem that says the strong force must be tuned to the precision required for carbon. The values are inputs, not outputs. The universe behaves as if someone set them and then walked away. You might want at this point to reach for an easy answer. Maybe the constants only look fine-tuned because we don't yet understand the deeper theory. Maybe a future physics will reveal that they had to take these values. That is a hope, not an argument, and it has a problem. The hope has been on the table for 50 years, and every serious attempt to derive these constants from a deeper theory has either failed or made the problem worse. String theory, which was supposed to unify all the forces and predict the constants from first principles, did the opposite. It predicted around 10 to the 500 different possible vacuum states, each one corresponding to a universe with different physical constants. Instead of one answer, it offered a forest of 10 to the 500 answers, with no rule to pick the one we live in. Leonard Susskind, one of the founders of string theory, looked at this landscape of possibilities and made a move that split the physics community. He suggested that all of those vacuum states might be physically real, not abstract possibilities, actual universes, each with its own laws of physics, each invisible to the others. If that is true, fine-tuning vanishes as a mystery. Of course, we live in a universe with the right constants. We could not exist anywhere else. The dials look set because we are sitting in the one room where they happen to be set correctly, and we cannot see the infinite other rooms where they are not. This is the multiverse. It is not science fiction. It is the conclusion several of the most serious physicists alive have arrived at, including Andre Linde, who developed the theory of eternal inflation. In Linde's picture, the inflationary expansion that drove the early universe never fully stops. It keeps producing new pocket universes forever, each one cooling into its own laws, its own constants, its own history. We are in one pocket out of an infinite number. The fine-tuning is a selection effect. Out of every possible universe, you can only ever find yourself in one that allows you to find yourself. It is a clean answer. It also has a price. The other universes, by definition, are causally disconnected from ours. No light from them will ever reach you. No experiment will ever detect them. To accept the multiverse as the explanation for why the universe is tuned for life is to accept an infinite ocean of unobservable reality, an ocean we are forced to believe in because the alternative seems worse. This is where physics, real physics, runs out of room. Because there are only a few logical possibilities left on the table, and physicists know it. Either the constants of nature have to take these values for some deep reason no one has discovered yet, despite half a century of failure to find it. Or there are infinite universes with all possible constants, and we live in a habitable one for the same reason fish live in water. Or the universe is, in some sense, that physics is unequipped to articulate, set up, tuned, aimed. Whatever word you want to use for the suggestion that the values were chosen rather than rolled. The cosmologists John Barrow and Frank Tipler spent 600 pages in their 1986 book The Anthropic Cosmological Principle working through the implications of the first two options. They distinguished between a weak anthropic principle, which simply notes that observers can only observe universes that allow observers, and a strong anthropic principle, which holds that the universe must, in some sense, produce observers. The weak version is almost a tautology. The strong version is a statement most physicists are extremely uncomfortable making because it sounds like teleology, like purpose, like the universe was aimed at us. And here is where the question planted at the start comes back. You were told the worst prediction in physics suggests that what we call reality might not be what it seems. Now you can see why. If the cosmological constant should be 120 orders of magnitude larger than it is, and yet here we are, in a universe where it isn't, then one of three things is true. Either there is a law we have not yet discovered that forces it to be small and the rest of physics has been blind to it for 50 years, or there are infinite universes and we got lucky, or the value was set. There is no fourth option that survives serious scrutiny. Every physicist working today has to choose between these three, even if most of them prefer not to say so out loud. Each of them changes what existence means. If the first answer is correct, then there is a master equation underneath physics that we have not found, an equation that knows about the conditions for observers, that determines its own constants in such a way that complexity becomes inevitable. Reality is then a kind of self-consistent puzzle that solves itself in only one way, and we are part of the answer. If the second answer is correct, you are one observer in an infinite ensemble, and almost everything that exists is forever beyond your reach. The universe you can see, all 100 billion galaxies of it, is less than a single grain of sand on a beach that has no end. Most of reality is not just unknown, it is, by the structure of physics itself, unknowable. If the third answer is correct, the universe is not the random outcome of blind processes. It is something closer to a result, and whatever produced that result is not part of the physics you have been taught. It is upstream of physics. It is upstream of time, of space, of the equations themselves. There is no comfortable choice on this list. Now picture where you actually are. You are sitting somewhere on the surface of a planet, 4.5 billion years old, circling a star that will eventually swell up and swallow it. The star is one of 200 billion stars in a galaxy that is one of 2 trillion galaxies in the part of the universe we can see. The atoms in your body were forged inside earlier generations of stars that exploded so that the carbon in your hand and the iron in your blood could exist. Every breath you take depends on a chain of cosmic accidents stretching back almost 14 billion years, and every link in that chain depends on numerical constants that, as far as anyone can tell, did not have to be what they are. The image drifting on the screen in front of you right now, the slow turning of stars, the dark between them, the long quiet of deep space, is not a backdrop. It is the thing that was tuned. And the fact that you can see it at all, that there is something in this cosmos capable of looking up at it and asking why it is here, is the most improbable feature of the entire arrangement. The universe is not just compatible with observers, it seems to insist on producing them. Or it has rolled the dice an infinite number of times in places you will never visit. Or there is a deeper rule hidden inside reality that pulls all of physics toward the conditions that allow minds to wake up inside it. Choose any of the three, and your sense of what existence is has to change. You cannot stay neutral. You are already inside the picture. You are already one of the data points. Whatever the answer turns out to be, it is also the answer to the question of what you are. This is what it feels like to look at the worst prediction in physics and not look away. It is not a problem with a calculation. It is a crack in the floor of reality. And on the other side of the crack is one of 3 answers, each of them strange enough to keep you up at night. We do not know which one is true. We may never know. But we know the answer must be one of them, and that alone is enough to change the way you walk through a normal day. The constants did not have to be these. The cosmos did not have to be here. Out of an unimaginable space of dead universes, you are inside the one that breathes. Either the breath was inevitable, or it was multiplied infinitely until one of them gasped your name, or it was set. There is no other door. The stars on your screen are old light, cooled by billions of years of travel, and the universe behind them has been balanced on a knife's edge since the moment it began. We are standing on that edge now. We have always been standing on it. The strange thing is not that the universe seems tuned for us. The strange thing is that we noticed.